Today on Capechi's Corner, we're going to talk about division properties of exponents, and this is day 2. Today we're going to work with negative exponents, and one thing we need to know is when simplifying an expression, you cannot have a negative exponent in your final answer. If you do, that expression is considered not completely simplified. So I like to have this phrase that's saying if the exponent is negative, you need to move it across the dividing line. The base will stay the same and the exponent becomes positive. So that means if it starts as a numerator and the exponent is negative, you're going to move it across the dividing line and it'll become positive. Same thing for vice versa. If your exponent is negative and your base is on the denominator, you're going to move it across the dividing line into the numerator, the base stays the same, and the exponent becomes positive. We will do a lot of this today so you can see a little bit more specifically what I'm talking about. And the big question I like to say to help us with this process is you should ask yourself, does it stay or does it move? And that is what you're going to ask about every coefficient and every variable you're working with. Here's our general rule. If I have a to the negative n power, a is a numerator, so I need to take that a across the dividing line, it becomes a denominator, and that exponent becomes positive. This can only work if a is not equal to 0. In my next example, my negative exponent appears in the denominator, so I'm going to do the same thing. My base will stay the same. I'll move it across my dividing line, so now that b is a numerator, and my negative exponent, negative n, now becomes positive n. Again, that will only work if b is not equal to 0. So if I'm looking at my two basic examples in letter A, I have x to the negative 4 power. Again, this is a numerator. If it helps you to put it over 1, you can. I'm going to go across the dividing line, so my x is going to become a denominator, and that negative 4 now becomes a positive 4. So in the end, my final answer is going to be 1 over x to the 4th. In letter B, my negative exponent is in the denominator. So again, I'm going to come across the dividing line. It's going to end up being in my numerator spot, and my negative 7 is going to become positive 7. Okay, let's start looking at some examples, and the directions say to simplify. So number 1, I have 2 to the negative 2. Now again, remember 2 is a numerator. It's really over 1. So I'm going to come across the dividing line. That 2 is going to stay 2. The base is the same. This exponent becomes a positive. Now I'm going to left with 1 on the top. It doesn't become a 0. It is really just 1. So my final answer, I'm going to simplify. I have 1 over 4. And number 2, again, my denominator has the negative exponent, so I'm going to come across to my numerator spot. And my y is going to stay the same. My negative 4 becomes a positive 4. So my final answer there is y to the 4th. Now in number 3, we're going to ask her a question for each coefficient and for each variable, does it stay or does it move? So I first like to just draw a dividing line and go look at them one at a time. So negative 2 is really raised to the first power, which is a positive exponent. So that stays where it is. It's a numerator, so it's going to stay as a numerator. My x to the negative 2 obviously has a negative exponent. I'm going to cross a dividing line, and that becomes a positive 2. Y to the negative 3, same thing, it's a numerator, crosses the dividing line to the denominator, and becomes a positive. Now the z is really z to the first, even though we don't write it. That z is a positive 1, so that's fine where it is. So there's my final answer. Negative 2z over x squared y cubed. And looking at 4, I realize I have parentheses, so I have to raise my coefficient to that power as well as my variable. So it's going to give me 5 to the negative 2, and then 6 times negative 2 gives me negative 12. Now again, this is really all over 1. That's a numerator. Now I know I can't have a negative exponent, so I'm going to draw my dividing line, and that 5 is going to go to the bottom, and I'm going to get a positive 2. Again, I'm going to bring my a across the dividing line so that negative 12 can become a positive 12. And again, I have my 1 as my numerator. So when I do my final cleanup there, I have 1 over 5 squared is 25, a to the 12th. And there's my final answer right there. And looking at number 5, I have a fraction raised to the negative 1 power. So let's get started with that. I want to get rid of my parentheses. So I'm going to take negative 4. I'm going to raise that to the negative 1 power. And then x, remember power to a power I multiply. So I have x to the negative 2. Draw my dividing line. My denominator, my coefficient's 2, so 2 also gets raised to the negative 1 power. And then there's my x, and again, negative 1 times negative 1 gives me positive 1. So again, now I'm going to ask my question, does it stay or does it move? So I'm going to draw my line again. Negative 4 to the negative 1 power goes to the other side of the dividing line and it becomes a positive. Now remember the base stays the same. So this negative 1, my exponent becomes positive, but that negative 4, which is the base, stays as a negative 4 because the base doesn't change. My x to the negative 2 power, again, goes across the dividing line and becomes positive. Now I'm done with my numerators, and I need to look at my denominators. I have 2 to the negative 1 power, again, goes across the dividing line and becomes positive. And x to the first power is fine where it is as a denominator, so I'm going to keep that there. Now I'm going to do a cleanup. So I have 2 to the first power on the top is 2. Negative 4 to the first power is only negative 4. And then I have x to the second times x to the first. Remember, I add my exponents there, and I have x to the third. Now I need one final cleanup. This 2 over 4, that simplifies to negative 1/2. And again, it doesn't really matter where you put that negative sign. We usually see it as a numerator or in front of the fraction bar. And then x to the third is fine where it is. So my final answer is negative 1 over 2x to the third. Let's look at number 6. Now this time in number 6, this negative sign a lot of times gets students confused. That's the coefficient. That's really negative 1. So I can't forget about that. I'm going to take that, my negative 1, my coefficient, raise it to the negative 3 power. And I'll take y and raise that to the negative 3 power as well. Now my denominator is 2. I'm going to raise that to the negative 3 power. Now I have a lot of negative exponents there, obviously, since my original has a negative 3, so I need to start moving things around. Negative 1 to the negative 3 power goes to the other side of the dividing line. Exponent becomes positive. Same thing with the y. Y goes to the other side of the dividing line and becomes positive. Now looking at my denominator, I have 2 to the negative 3. So I'm going to move that across the dividing line and make that a positive 3. Let's start simplifying. 2 to the third power is 8. Negative 1 to the third power is negative 1. And then y to the third is fine where it is. So if you look at my coefficients, I have 8 over negative 1, which gives me negative 8. And then y to the third in my denominator is fine where it is. So that's going to be my final answer there. Negative 8 over y to the third. Looking at number 7, there's a lot of different ways we can attack this problem. So as long as you're following the rules of algebra, it's okay. So in number 7, I have y to the negative 4. So again, I'm going to bring that to the other side of the dividing line and become positive. That x to the third is fine where it is. I have a positive exponent, so that's going to stay. I'll put that in front because we usually do things alphabetically. So again, I have a 1 on the top. So in my next fraction, I have x to the fifth over y raised to the negative 1 power. So I take x, and then I have 5 times negative 1, which gives me negative 5. And my denominator there is going to be y to the negative 1. So let's start simplifying. So across, I have a 1 on the top, and I have x to the third, y to the fourth. That's fine where it is. Now I'm working with this fraction. Then x to the negative 5 goes to the other side of the dividing line and becomes positive. My y to the negative 1 again goes to the other side of the dividing line and becomes positive. So let's do our last cleanup there. I have 1 times y to the first as my numerator, so that can just stay as y. And then I have x to the third and x to the times x to the fifth, which gives me x to the eighth over y to the fourth. Now again, from here I have my y's here. So I have 1 over x to the eighth, y to the third. Right here, my y's, I have y to the first over y to the fourth. I subtract them, I'm left with y to the third as my denominator. And looking at number 8, in both my numerator and my denominator, I have a coefficient, and I have 3 variables for each. So I am going to ask that question, does it stay or does it move, to start simplifying. My negative 8, remember my coefficient is raised to the positive 1 power, so that's fine where it is. My x to the ninth is positive, so that can stay where it is. My y to the negative 3 is going to go to the other side dividing line and becomes positive. My z to the negative 4, other side dividing line, and becomes positive. Now look at my denominator. That 24 again is 24 to the first power. My coefficients usually go up front, so I'll leave it there. That's fine where it is. X to the negative 11th, because the other side dividing line becomes positive. Y to the negative 6, again, other side dividing line, and becomes positive. And z to the fourth is positive, so it's fine where it is. Now let's start cleaning up. I have negative 8 over 24, which is really negative 1/3, so I can simplify that to negative 1/3. My x's are both numerators, so I can add them, so I get x to the 20th. And then my y's, I have y to the 6th on the top and y to the 3rd on the bottom. So when I simplify that, I subtract. I get 6 minus 3 gives me 3. So I'm left with y to the 3rd as my numerator. And my denominator, I have z to the 4th times z to the 4th, which gives me z to the 8th. So when I simplify that, I don't really need that negative 1 in front. So my final answer, I need the negative sign but not the number 1. So I get negative x to the 20th, y to the 3rd, all over 3z to the 8th. Let's look at our last problem for today. In number 9, again, there's a couple ways we can do this. We can simplify each fraction and then multiply. I like to simplify by multiplying my numerator across and then my denominator across and simplifying all at once. So let's just look at our numerator. If I take 3 times 12, that gives me 36. I have x to the negative 2 times x to the negative 4th. Remember, when I'm multiplying, I can add my exponent, so I get x to the 2nd. And I have y times y gives me y to the 2nd. In my denominator, I have 3 as my only coefficient, so I'm going to leave that there. Now I'm going to rewrite these. I'd like to line them up in columns with the coefficients and then each variable. It makes it a little easier for me to simplify in the end. And then I have x, and then I have y to the negative 6. Now the only thing that's really going to give me a problem here is that y to the negative 6. I really want that to be positive. So let's clean that up again. So I have 36 x squared, y squared. They all have positive exponents, so they're fine where they are. My denominator of 3 times x, and this y to the 6 is going to go to the other side of the dividing line and becomes positive. Now I can start my cleanup. So I have 36 divided by 3. My numerator gives me 12. X to the 2nd over x gives me x to the 1st. And then y to the 2nd times y to the 6th gives me y to the 8th. So in the end, my final answer is 12x y to the 8th.